Okay, so when I see a problem like this, I think to myself first, I'm like, okay, so I see some exponents, I see some bases. Right now, they don't look like they're the same, but could they be the same? Because all those exponent rules, most of them have to do with common bases, like you can subtract them or things can cancel out. Also, when I see a fraction, even if there's variables, so as you get further into math, if you see a fraction like this, it looks kind of complicated. Chances are, right, there is some way in which to cancel out a bunch of common factors to really make it more simplified. That's usually the case. So they're like little puzzles sometimes when you see this. And one of the things I like about puzzles is sometimes they're kind of predictable. They're solved in similar ways. So that's kind of a clue that you're like, this is probably going to end up being more simple than it seems at first. All right, so I notice there's a 4 times 6, so that's good because a lot of those rules are things have to be multiplied or being divided by. This is addition. Okay, so I saw some people wanting to put this as 5 to the third and 1 to the third. Okay, that is not allowed. It has to be multiplying in here. Otherwise, what this is really, I'm going to scoot all the way down here. This is 5 plus 1 times 5 plus 1 times 5 plus 1, right? So really, this is 6 times 6 times 6. It is not 5 to the third, which is 125 plus 3. Or not even 3 plus 1. So it doesn't work out to be the same value, right? So, but what we can do is we notice notice they add up to 6, and 6 is a base we have right here, right? So when I see that, that's kind of what I think. I think, hey, if this becomes a 6, well, then this might be able to cancel out. And I think, well, could that work? Yes, there is a rule, if you guys remember, right, where this exponent goes on, right? It's the power of a product rule. So we could rewrite this as 4 to the third times 6 to the third times 6 to the third. So most of you guys multiplied this out to 24 to the third. 24 to the third is the same. It's the same value, but 24 to the third is not going to cancel anything out. But right here, right, these two things. So if you have a fraction, because really this is like 1 times this, right? This is a big giant 1. They cancel out. And so what you're left with is just 4 to the third. So that would have been the correct answer here. But it is a little bit of a puzzle. You're like, oh, Miss Mills, that's not fair. Well, I mean, you're not getting graded on this like you got it right or wrong. You're getting graded on, did you try and think? You did? Great. Now, think about what if you would have thought about it a little bit differently, right? Okay, so I'm going to give you another example to think about and try. Where did I write? There it is. Okay. All right, so I'm just giving you a heads up. Remember what we just learned, right? If you're adding between those bases, those exponent rules don't apply. They only apply if you are multiplying between the two bases, right? Which is really what is happening here. There's power to a power. So pay attention, be careful. Don't fall into the trap of pluses with those common bases. Those rules don't apply between addition. All right, go try that problem.